This is our quadcopter, Ariel. The frame is made out of 2 carbon fiber tubes held in an X pattern by 3D printed parts. The flight control system consists of a microcontroller and an inertial measurement unit for real-time control of the quadcopter's orientation, and a Raspberry Pi computer with a camera for facial tracking and sending commands to the microcontroller. Here's a demonstration of Ariel's manual flight mode while attached to a test harness. The test harness allows the pilot to stabilize and trim the quadcopter before hovering under its own power. It also protects Ariel in the case of the test pilot behaving erratically.
Let's try to go straight up.
We will now demonstrate Ariel's face tracking mode, which the pilot can enable by holding a trigger on the remote control. In a moment, the pilot will press the trigger. There. Due to an orientation initialization bug, Ariel veered off to the right when tracking mode was first enabled, but Ariel is now correctly following Griffin's face. This mode was originally going to be an automatic flight mode where Ariel would fly a fixed distance and position away from the user's face, using only the face detection model for position feedback. Unfortunately, our project was substantially delayed by many PID tuning issues, leaving this mode as a very basic proof of concept. Here, the pilot holds up the controller to prove that he's only pressing the mode trigger and not providing any other feedback. You may have noticed that Ariel rotates to the right much faster than to the left. This is a PID tuning issue that wasn't important enough to fix given our time constraints.
I think my derivative gain is a little...
Here we see Griffin striking a pose for a photo, which we can then go onto Ariel's web interface to download. On the left is Ariel's status page. On the right, you can see me pointing out Ariel's forward propeller. The arrow in Ariel's status page points in the same direction as that forward propeller's carbon fiber tube.
And if we point it down, it follows it down. If we point it up, it follows it up. And so now if we point it...
Here, we pointed the Earth's x-axis towards us on the page to make the roll orientation easier to see. The straight line off of the arrowhead points from the forward propeller to the left propeller, which illustrates the roll orientation of the quadcopter. It's difficult to move one axis independently from all the others.
The reason it's kind of going all over the place is my pitch and yaw are also changing. There we go, now I'm back to the center. It's kind of to pitch and roll at the same time.
Here we show the interactions between roll, pitch, and yaw.
And we can also combine any amount of yaw with all of those other things. Okay, so if you
Scrolling down, we see the view selector buttons. We are now viewing the joystick orientation.
if I yaw to the right,
Here's a demonstration of the joystick yaw.
if I yaw to the left, it goes all the way to the left. And then I can also combine pitch up.
Here's pitch.
So pitch back, pitch forwards, pitch back, pitch forwards. To see, I guess if I move it over here, it'll be a little easier for you to see that.
And here's roll,
Pitch and roll.
which is really hard to actuate separately from pitch on this controller in particular.
Roll left, which makes the head go down.
Lastly, here's a quick demo of Ariel's web interface in its entirety. Flight logs with debugging information are available here. Here's a shortcut to the latest flight log. This is where all the pictures you take are stored. There's a shortcut to the latest photo. Here's the components page with some trivia about Ariel, and this is the status page from before. Instructions for using the controller are available at the bottom of the main page. Thanks for watching.